This lesson is rotation. So you've probably had some form of rotations in the past. You probably flipped your paper over, stuff like that. So our learning target is I can rotate figures. So rotating a figure is just a turn, so turning it over. Okay, so if you look at the picture, ABC is this triangle right here. So that's your pre-image. You know it's the pre-image because it doesn't have apostrophes on the letters. And so I'm going to do the blue one, that'll be our image. And we know that that one is the image because it has A apostrophe, B apostrophe, C apostrophe. And remember that we call that A prime, B prime, C prime. Okay, so notice that it has flipped over, not flipped over, let me say that again. It has turned over, so that's what a rotation should look like. Okay, so a rotation is a turn around a fixed point called the center of rotation. So when we talk about the center of rotation in this class, we will only talk about the origin, or if you don't remember what the origin is, the point 0, 0. So every time we rotate something, every time we turn something, we're going to turn it around that point 0, 0. Okay, some other things to remember is that a figure rotates at a specific angle. And for our class, we're either going to rotate 90 degrees, 180 degrees, or 270, and direction. And there's only two directions we're going to talk about, so clockwise and counterclockwise. So clockwise, remember, is the opposite of a clock, and then clockwise would be the way the clock goes around. And anytime it doesn't say, you can automatically assume it's counterclockwise. Okay, so let's look at our geometric rotation rules. I think it's kind of easier just to show you these and show you how you work with them. So for 90 degrees counterclockwise about the origin, XY, the pre-image, and then we're going to use an arrow to show that a transformation has happened. And then for the image, it's going to be negative y comma x. So the original y coordinate is going to move to the very beginning of the parenthesis, and it's going to have the opposite sign. And the original x coordinate is just going to move to the back of the parenthesis, but it'll have the same sign. Okay, and also remember that 90 degrees counterclockwise is the same as 270 clockwise. Alright, so then the next one is the 180 degree one. So here's how we do this one. We're going to say XY, the pre-image, transformation happened. Here's the rule for how you find the image points. So this one is negative x, comma, negative y. So all this means is that the two coordinate points, they will not switch places. They'll stay in the exact same places, but they'll have the opposite sign. So if they were positive, they'll now be negative. If they were negative, they will now be positive. Okay? And 180 degrees, it does not matter if it's clockwise or counterclockwise, because 180 degrees is the same thing. Okay, and then 270. We're going to start with x comma y, our pre-image, arrow for transformation happened, and then to find the image coordinates, it's going to be y comma negative x. So the x and y coordinates are going to switch places, and the original x coordinate is going to have the opposite sign. Okay, so those are the rules. You'll need to know them. You'll need to know them for the test. If we take the final exam, you'll need to know them then. I think you should memorize them, but I'm not supposed to say to memorize anything. But I just did. Don't tell anybody. Okay, here we go. So here's our first example. Triangle ABC with vertices A is 2, 7, B 6, 5, and C is 4, 1. I want you to go ahead and graph that and label it. And I'm going to do it in 2 separate colors, so if you want to, you can. If not, it's cool. So graph it and label it. Alright, so there's my pre-image. Now we are going to rotate this 90 degrees counterclockwise. So here's the rule for that. You have x comma y, that's your pre-image point. Transformation happened, and then to get the image points, we're going to go negative y comma negative x. Okay, so I started with 2, 7. This says that I'm going to switch the coordinates, so it's going to be 7, 2. Oh, and I just realized that I wrote the wrong rule. Oh my goodness. Okay, hold on. I got a little excited or something. This is not supposed to be here. Okay. So still, we're going to switch the coordinate points. And notice that the original y coordinate is the opposite. So the original y coordinate was 7. The opposite of a positive 7 is a negative 7. So now my new point is going to be negative 7, comma 2. Alright, and then we're going to do the same thing with the next one. Okay, so the pre-image for B was 6, 5, and now we need to find the image for B. So this says that I'm going to switch my coordinates, and my original y coordinate, the 5, becomes the opposite sign. So it's going to be negative 5, comma 6. And we'll do the same thing for the last point. So my pre-image point for C was 4, comma 1. The rule says to switch the x and y coordinates, and the original y coordinate becomes the opposite sign. Okay, so now I want you to graph and label that, and I'm going to do it in a different color so I can see it a little easier, but we should see that it turned. Alright, and there we have it. So notice that it definitely went in a counterclockwise motion, and then because we wanted it to go 90 degrees, here's my little trick for that. Notice that the entire blue triangle was in this quadrant over here. Every time you move 90 degrees, you're going to go over one quadrant. So we went 90 degrees and all of the triangle ended up in the next quadrant. If we went 180 degrees, we would expect to move 2 quadrants over. If we went 270 degrees, we would expect to go 3 quadrants over. And if we go 360, we expect to be in the same exact place. Okay? So celebrities, when they come out of rehab, they're like, I made a complete 180. That's good. But when they say, I made a complete 360, that means you're still on heroin. So go back to rehab. Okay, so that's the little thing to remember. 360 gets you back to where you want to be. 180 means you actually turned around. Okay. So let's do this one. Go ahead and graph this square, PQRS, and label your vertices. Okay, so there's our square. Notice all of it is in the first quadrant. We are going to rotate this 180 degrees. Notice it doesn't tell us counterclockwise or clockwise because they're exactly the same. And then so you need to know that the rule is negative x comma negative y. So the coordinates will not switch places. They'll just change to their opposite signs. Okay, so hopefully this makes sense. And then also, we just talked about it, if it's going to move 180 degrees, I'm going to expect it to move 2 quadrants over. So I expect this square to be somewhere over here. And it should not look like a reflection, it should look like it has turned. Okay, so my first point was 2, 6. I'm not going to switch the coordinates, I'm just going to change both of those to the opposite sign. So they were both positive, now they will be both negative. Then I had the point 6, 5. All I'm going to do is change them to their opposite sign. So it's going to be a negative 6, negative 5. Same thing with the next one. It started off with 5, 1. Changed to opposite signs. It's going to be negative 5, negative 1. And then the last one, the same thing. It started off with 1, 2. It'll now become a negative 1, comma negative 2. So I want you to go ahead and graph that, label it, and let's make sure that it is in the correct quadrant and it looks like it has turned. Okay, so it moved in a counterclockwise or clockwise rotation. That's why it doesn't matter. It moved 2 quadrants over, so that makes sense for 180. And it does not look like a reflection. It looks like the figure actually turned. Alright, let's do the same thing with this one. Go ahead and graph your rhombus CDEF, and then we'll talk about the 270 counterclockwise rotation. Alright, so we have a rhombus. It's in the second quadrant. Remember that if it's going to move 270, we expect it to move over 1, 2, 3 quadrants. So we expect it to be somewhere over here. And it should not look like a reflection, it should look like it turned. So here's the rule for 270. And then we're just going to apply the rule. So I started out with negative 5, 5. The rule says I'm going to switch my coordinates, and that the original x, the negative 5, becomes the opposite sign. So now it's going to be a positive 5, positive 5. Oh, I hit the pen, made it look ugly, sorry. Alright, and then the next one, so we had D was negative 1, 7. We need to switch the coordinate points. And then the original x, the negative 1, becomes the opposite sign, so it will now be a positive 1. So 7, 1. Alright, and then we have negative 3, 3. We're going to switch the coordinate points, and then the original x, the negative 3, is now going to be positive. So positive 3, positive 3. And then last one, we had negative 7, comma y. We're going to switch the coordinate points, and then the original x will be positive. So go ahead and graph this new rhombus, make sure it's in the right quadrant, and make sure that it looks like it has rotated. And that figure makes sense. So it moved 3 quadrants over, which is what we expect with 270. It definitely is not a reflection if you look at the coordinate points. If you didn't label the coordinate points, you might think that one is a reflection. But if you look at like D to D prime, that's not a reflection, it turned. If you look from F to F prime, it turned. C to C prime looked like a reflection, kind of, and E to E prime looked like a reflection. But the D and F is where you see that it's not a reflection, it actually turned, which makes it a rotation. So all of this stuff is very important that we're doing, that when you take your test, I want you to continue doing. Make sure you're labeling things. If you like color coordinating and that helps you see stuff, do it. Okay, so I want you to try this one, and I want you to pause the video, and then if you get stuck, just push play, and maybe I can help you, and then you can push pause again and try it. So go ahead and pause the video in 1, 2, 3. Okay, so the first thing that we need to do is to graph triangle GHI. Alright, so I've graphed GHI. The next thing I need to know is what is the rule for 270 counter. So it starts off with XY, a transformation happened, it becomes Y, negative X. So they are going to switch places, the coordinates, and then the original X will be negative. So I'm going to take that point 0, negative 2. I'm going to switch places, and then I'm going to make the original x negative. However, 0 can be neither negative or positive, so you really don't even have to worry about that one. Fine, fine, fine. Alright, next one. You got 7, negative 6. I'm going to make these switch places, and then I want my original x, the 7, to become the opposite sign. So this one's going to be negative 6, negative 7. And then the last thing I'm going to do is I'm going to take that point 3, negative 8. I'm going to switch the coordinate points. And I want my original x coordinate 3 to be the opposite sign. So it's going to be negative 8, negative 3. Now I'm going to graph these and I'm going to make sure it makes sense. That is horrible. Don't look at that. Okay, it should look better than that. Alright, so we started off in the blue quadrant. We went around 1, 2, 3 quadrants, so it makes sense that it's in that quadrant. Also, it does look like it has turned. It has went all the way around counterclockwise like we wanted to. It does not look like a reflection. So yeah, we did a good job. And that is the end. So as long as you know the rules and you can figure out what they're saying, I think it's really easy. Make sure you're labeling things because that will bite you in the butt, I promise, if you don't do that. Okay. So if you need extra help, then you can email me, send me a message through the Remind app, and you can always set up a Google Meet. If you want several people on it, we can do that. And if you're ever on campus, I'm on campus Monday through Friday, 8:30 to 3:30. You can swing by. Make sure you're wearing a mask so we don't all get sick. Okay, bye.